Welcome to the NGConnects Podcast, where National Gypsum team members and industry leaders share insights and advice to solve construction and design challenges. We obsess over the details that help you build better. Well, hello you two. Great to have you. Today I'm with Jordan Jarvis, Scott Hughes, two construction design managers for National Gypsum. You guys bring a wealth of knowledge, years of experience to the industry, so really excited to talk to you today. We're discussing fire and sound solutions by building type. Again, Construction design managers, really excited to get into things. And to start, I know for years, and I was in field sales, got a lot of questions about fire ratings. I understand the questions that we received was probably about fire ratings. Mm-hmm. Lately, though, acoustics has become more of a top contender when it comes to the questions that we get, that you all get. So can you just explain why maybe the sudden shift in why we're getting all these acoustical questions now?
So that's a good question. I believe that we started to see a trend of this about 10 years ago. And if you think about it, that was around the time of the market crash where a lot of people were moving from single family homes into multifamily. So that means that now you have neighbors or someone constantly on top of you, underneath you, and on either side of you. Mm-hmm. So sound has become very important then. And if you think about, working in an office space or going to just different buildings, we're just constantly having occupants all around us. So sound has definitely become an important topic. Yeah,
so the acoustics tie with the fire rating is more important than ever then. Mm-hmm. Yeah, and obviously when it comes to quiet environments too and the benefits of that, I mean, that's a great way to explain it.
Not only do you want the safety from fire protection, but you also want to be comfortable where you are, not hear your neighbors.
Peace of mind, right?
Yeah.
And it's also important that you don't give up one for the other, because when we're looking at, picking a UL assembly for a commercial project, and we're also trying to achieve a certain STC assembly, you don't want to mess up your fire rating by going for a certain STC rating. So we've got a great resource in our fire and sound selector that will help folks kind of dig through some of that as well.
Awesome.
There was actually a survey that was done a couple years ago by the National Research Council of Canada, and they surveyed about 600 people that were living in a complex with about 300 party walls between them. And they were able to find that the residents with lower STC rated walls were more likely wanting to move due to the noise. They were being awakened by noise, so their sleep was disturbed. And really just thinking that their neighbors were less considerate and they just really wanted to move. Yeah.
Yep.
Yeah, I know I've stayed in my fair share of hotels as well where I'm like, I think I hear someone next to me. And I mean, we're going to get into that and why that happens. But so before we're going to get into three different building types that we'll discuss acoustical challenges and various solutions to how architects can view this building type to better improve the building as a whole. And when we dig into acoustics, we hear STC ratings. So can you let's do a quick acoustics 200 refresher.
Sure.
What is STC rating? What does it stand for? What is it actually measuring?
So STC is sound transmission class, and we have to be able to compare wall assemblies on how they'll perform at reducing sound through it. So that's the STC kind of gives us a guide on how much sound is reduced from one side of that wall partition to the other side. And we do that through testing. We make all kinds of noises at different frequencies. We throw these frequencies out of a speaker through our test wall. And on the other side of that test wall, there'll be a microphone. Mm-hmm. It's a little more complicated than that, but that's kind of the general thought. And then that microphone pulls in how much sound is actually getting through, and then an STC is generated. So architects generally are looking for an STC 50 in most of their walls. Code kind of requires that depending on the building type. And we're going to talk a little bit about that, as you mentioned, later. So what is a 50? It's hard to define because we all hear differently. All three of us here are going to hear a little bit differently. Yeah. The older we get, the harder it is for us to hear. That's just, we all have parents, we know, right? You have to speak a little louder, right? Yep. 50 would be a wall where I could speak as loud as yelling really loud. You'd be on the other side of it, and you might hear some sound, but you probably won't know what I'm saying. Okay. If you go down to like a 45, so we drop 5 points of STC, that's pretty significant. So at that point, I'm yelling, you might pick out a few words. Mm-hmm. At 40, I probably don't have to yell, that kind of thing.
So, Scott, we hear a lot about decibels. People are familiar with the word.
Right.
What is a decibel? Can you just explain how that works?
Think volume, right? Think volume. If the three of us here in this room are probably talking to each other somewhere around 60 decibels. In a school atmosphere, the teacher in the front of the room with a bunch of kids in the room probably has to elevate her or his voice to about 65 decibels, right? So you have to elevate a little bit. Jordy and I do a lot of presentations in conference rooms, and depending on the size of the conference room, we'll be at 65 decibels at a minimum, right? Because your bodies absorb sound. So the whole idea with our wall partitions and why we talk about STC ratings is to reduce the amount of sound through it. So therefore, we want to lower what we hear on the other side. So a 5 decibel change, let's go from 60 decibels to 55. So we've reduced it, we've quieted. That's significant where we as adults hear that. But from a 60 decibel to a 58, we don't really click that anything's different in the sound. Now going the other way, so a 60 decibel to 65, you would know that I'm really starting to talk really loud, right? I'm really elevating my voice. Once you get to 100 decibels, if you're exposed to 100 decibels for a given amount of time, it will actually cause physical pain in your ears. So think indoor rock concerts, right? Think AC/DC or any of these very heavy metal bands that really just crank up the speakers. So we obviously it's a little more dramatic than what we do for a living here, but the goal is to reduce the amount of decibels getting through our wall partition by at least 5 to 7 decibels. 10's great. A 10 decibel change is twice as quiet if we're going down. 10 decibel change going up is twice as loud. So it starts to do a lot.
Awesome. That's a great way to explain it. Yeah, and I think what I got there too is whenever we find an STC rating, it's all done in a, let's say, lab. Everything is perfect situation, perfect setup. And we talk about STC ratings and how we measure that. Now let's talk about the actual field. Like when architects are designing, everything's on the paper that looks perfect. When we're out in the field, it could be different. Why does this perfect wall that on paper looks good, why does it fail typically out in the field? What are those challenges that we're seeing?
So I wouldn't say that it's a fail per se. I would say more so that the STC rating would be different. And like you said, labs, I mean, it's a perfect situation, right? Kind of pristine circumstances, and the scientists or whoever's engineering those tests can kind of make it perfect. But once you have that out in the field, obviously the field is not going to be perfect in perfect conditions or clean. And I think, Scott, you say it the best way.
Yeah, there's no such thing as a right angle on a job site. It just doesn't exist. The only right angles we find are on the drawings that you have in the job trailer and then on your computer screen. You go on a job site, there's no such thing as a flat line on a job site, right? So we know that in the industry, and we know that when we're testing, like Jordy said, we're wearing lab coats, every screw is set perfectly, everything's done perfect. It just doesn't happen on the job. So we have to allow for that.
Now, are there specific problems that architects should account for when designing walls, like flanking paths, for example? Like, again, what exactly are those problems that cause maybe those issues out in the field?
Well, sound is a system, right? And sound, I think, is the best way described like water, where water just kind of flows to the least resistance. So sound is the exact same way. You can have a perfect assembly and then use, perfect cavity insulation, perfect products. But if there's a penetration in that wall, the sound is going straight through that, and that is what flanking sound is. So we do have some best practices that we can go through later in the conversation. But yeah, sound is like a system, and it goes through the least resistance.
I think that's a perfect way to explain it too. Yeah. So as we're talking about building this perfect wall, and obviously, like we're discussing, you can't really build a perfect wall. What other problems are architects going to run into when designing these walls for certain buildings?
If you've ever been in an old house and you're sitting in a chair like we're sitting here on an exterior wall, and you happen in the wintertime put your hand down by an outlet on the exterior wall and you feel the cold air blowing through, right? Most of us have felt that at our grandparents' house or something, right? That's allowing air, obviously, to get through. So if air gets through, Jordy had mentioned water gets through, sound's coming right through theirs too. So that we use putty pads. So the electricians know what they are. They know how to get them. Once the wires are put through the back of the box and they put the outlet in there, they can wrap them. Think of silly putty. It's just a big thing of silly putty around the backside of the putty pads. Where it's not an outlet, maybe it's a crack or it's a seam. It's the bottom of the wall where the drywall, it doesn't go all the way to the floor. We need to caulk it. We need to use some kind of a flexible sealant and caulk it before we finish those joints.
We're going to dive into 3 different building types now, all commercial construction that we're seeing a lot of as of recent: healthcare, multifamily, and education. So let's get into healthcare first.
It's a little bit easier for new construction because you can design the rooms and put the noisy stuff like MRI machines and things that make a lot of noise, away from patients. When you're doing renovations, it's a little bit more difficult. You're kind of stuck with what you got.
Yeah.
But a typical, you need an STC 50. There are guidelines out there. There's several organizations that kind of give architectural firms guidelines on what an STC needs to be in between patient rooms or cafeteria and patient room, things like that. Schools the same way. So it's just you've got to take into consideration what you mentioned, and that's all the noise. Every machine's making noises, and they're on purpose. Nurses in their nurses station need to be able to hear things and monitor things.
Yeah.
When doctors come in to talk to the patient about either lab results or what their treatment's going to be, it's a private conversation, so we have to have high STCs, and it's difficult because there's so many things in a hospital wall: oxygen and electric and IT and everything else.
So space constraints are huge then too.
Yeah.
We talk about again building hospitals specifically, and then the space limitations that there are. So how can architects find a way around the possible space limitations that they're facing?
Well, our sound break, we have a gypsum board, 2 layers of gypsum with a viscoelaster polymer in between. Total thickness would be a 5/8, which is good because that's kind of the standard thickness in commercial work. It's a Type X product for your UL designs. And it will keep the wall thin, but still get you those STCs of 50 or higher. And we have to look at the parts and pieces of a wall assembly. I can't just say, hey, every time you use it, it's going to be STC 50 or 55. It depends on studs, spacings, things like that, insulation. But like you mentioned, like hospitals, schools, multifamily, they want every square inch of floor space. Yeah. So to keep that wall thin and get an STC 55, that's where the sound break or the soundboard comes into play. If you can build a 7-foot wide wall, it's going to be pretty quiet, right? But for what we do for a living, we need to keep it thin.
Well, absolutely. From a cost efficiency standpoint and from a space standpoint, I understand completely. Well, I think it's perfectly touched upon with hospitals. If we want to transition next into multifamily, as you live in an apartment, I've lived in an apartment before. We see them being built everywhere nowadays, specifically. So what's like a magic STC number for these projects? How do we get there? What are some, again, unique challenges that architects might be facing when it comes to multifamily?
Yeah. I think the minimum still is SCC 50 that they're trying to achieve in those walls. I can tell you, living in an apartment, I battle this every day, where you can still hear, your neighbors and even in the other room. And I think a big thing to that, or a big reason, is because everyone is putting TVs on the wall, right? And we have TVs in every room, right? So I think, again, going back to penetrations, those penetrations in the wall, it's just tearing down or not tearing down, but bringing down that SCC, and you can kind of hear. Yeah,
the fasteners they use for those brackets almost go through the whole wood stud. So that's just vibrational energy goes right through.
Yeah.
So again, anything... We bring this up if I find something at an antique store and want to just put it right on the wall and drill through the studs, it probably is going to affect the STC rating.
It probably will.
Absolutely.
That's good to know. Yeah. So what are some best kind of workarounds then? If there's recommendations, obviously, on what to do, how can architects design these multifamily, whether it's, again, decoupling, resilient channels? Let's touch on that a little bit to help find these, find solutions for these unique challenges that they're facing.
Yeah. I find that architects aren't really, or they're looking for options other than using an RC1 channel or decoupling the wall. And that makes sense, right? Because the occupants or the owners aren't going to know exactly which wall has an RC1 channel, right?
No, they won't.
Right. So they want options to where you don't have to do that. And I think Soundbreak is an excellent option for that.
Yeah, it's, when you're putting up cabinets on a wall, if you live in an apartment, you hear everybody's cabinets next door if they're in the kitchen, right? Plumbing sounds, flushing toilets, rushing water through the pipes. I mean, it's really hard stuff to mask. And there's products out there, other than what we talk about today, to help with all of that. But the sound, keeping that wall thin, the decoupling that's used in the board itself really performs well.
Okay.
Yeah.
What a resilient channel does for you is that it suspends the drywall off of the stud about a half an inch. So there's a small flange with holes in it so that they can hit studs. And then there's this angle that comes out, and it holds about a half inch long. And then you've got this large flange that goes up. And that gives the contractor room as they're trying to find their screw to attach it to the resilient channel. A couple things are key about it, though. Number one, those fasteners can't go through the resilient channel into the stud because we've just defeated the purpose of trying to decouple that wall by having that drywall off of the stud itself. And they need to be hung correctly as well. Those large flanges need to go up. We've gone to job sites and we've seen it up. We've seen one room down. You see them all at different directions. They need to be up. That's the proper way, because over time, like everything in this world, gravity pushes down on things. And as it does, it will pull that drywall away from it. So that's the theory behind resilient channel. It works really well, particularly in labs. The issue, though, is, and we've talked about it, the issue is, what are you going to hang on the wall? If you're going to start to hang heavy things on the wall, for instance, you go antiquing over the weekend, you find this huge ship's wheel that weighs 25 pounds, and I said, that's great for my wall. We're going to hang that sucker up there. You need a big anchor, and you need to find a stud, and they squeeze everything tight, and they've just defeated, we call it short circuit, the whole system. Yeah. So that's that. You have other options. You can go double stud walls. So that's another way of decoupling. And so decoupling is just separating so that there's nothing in between. So as that vibrational energy hits the one side, it's a lot harder for it to get through to the other side. It still can, but it's just a lot harder.
Let's get into the unique challenges and specifics on what are best practices when it comes to architects designing schools.
When you think about kids' education, the quieter the environment, the less distractions there are for the kids. So now we've got to look at every single wall in a school and say, all right, is this wall going to border the outdoors on the playground side? If so, that's going to be noisy. If there's kids playing, recesses at different times, different grades, we have to design for a good SDC of 60 or something high that really will mask that sounds. And then cafeterias, swimming pools, band rooms, where do we put all of those in relation to, where the kids need to not be disturbed because of the distractions that are going outside the hall?
Oh, yeah.
And if we talk about inside the classroom too, I get from room to room, completely get it. But if we talk about inside the classroom, and I know when we went out in the field and discussed this with architects or contractors, NRC, and the importance of having stuff on the wall, for example, can we kind of get into that on, again, why that is important?
Yeah, well, it is important, and you have a little one at home, so you definitely understand. Kids need quiet, right, in order to learn, and they need less distraction. So definitely inside of the classroom, you want to make sure that the STC is high so that the kids can learn. That's a big one. I think that there's actually LEED certification or LEED credit that you can get for that particular.
There's an acoustical credit that helps towards achieving that credit.
Yeah.
But the NRC, that reverberation sound, think of yourself in a gymnasium all by yourself. Nobody's there, just you. Basketball,
bunch of echoing, right?
At center court, bouncing that basketball. And I know we put padding for kids running around and that thing, but you're still going to get that echo. So that's that reverberation sound. It's important to hang things on the wall so that it absorbs the sound rather than it reflects it. Now, unfortunately, drywall is going to reflect sound because it's hard. It's a hard surface thing. So that's why we have to do other things in addition to soundboards about not going through the wall, but it's not going to help with the reverberation inside the wall.
Yeah. So
carpeting everywhere, you'll be fine.
Room to room's important, and just put carpet everywhere in the room and you'll be golden.
Either carpet or maybe draperies would be a better idea.
Yeah. But again, that's good to know, because I know there's a lot of classrooms nowadays that have become, let's call it modernized, and the less stuff in there, the better, but then that could cause some, obviously, some
think of
noise.
the movie theater.
Echo,
Last time you've went to the movie theater, it's draperies on the sides. Huge. I mean, they're huge, but that's to keep that loud vibrational energy from bouncing around the wall.
So we've covered a lot of ground today. Very valuable information indeed. So if I'm an architect sitting at my desk right now and trying to build out a partition wall, what resources does National Gypsum have that I can look at and hopefully get assistance with this.
So this is the fire and sound assembly selector that Scott talked about earlier. This is on our website. We use it daily. It's just a wonderful tool. You could see here, and if you're listening in on this podcast, I highly recommend jumping over to our YouTube channel so you can see video overview of us using it. But you can see that we start with over 300 designs, right? And you can filter it. If you're an online shopper like myself, this is a great tool to use. But you can see that we can filter the assembly type. Let's do walls and partition. Fire rating, of course, you want to get a 1 hour at least. Framing, let's do stick framing, wood. SCC rating, this is the important one. You can select your filtering or select your STC rating that you're wanting. So, of course, you want to do a minimum of 50.
But you can do more if you wanted to.
Yeah, you can do more if you want to. Stud spacing, stud sizing, and you could see that it drops to the resources that actually have what we filtered, the designs that we actually filtered out. So, once you click on them, you could see that you have different files that you can download, like CAD, Revit. You can go to UL site. It's an amazing tool, and we use it every day.
Seems incredibly easy to use, too.
Oh, very, very easy.
So thank you for sharing that.
Yeah.
Great. Like I said, easy tool. Definitely seems. What other resources does National Gypsum provide besides that tool?
Well, our website is phenomenal. It's absolutely phenomenal. You can access a lot of our reference books there and download them. We also provide hard copies of them, but we've talked a lot about the sound book today with the tested partitions for STC ratings. We also have what's called the Purple Book. It is a UL reference type resource where it is all metal construction, head of wall details, intersection of fire rated walls, priority legends, elevator shafts, horizontal lid and corridor detailing. Just hard to find stuff. Your partition doesn't line up with the beam. How do you fire stop it? So it's a wonderful resource there. It's called our Purple Book. For those that do the stick framing or the wood frame construction, we have the same thing as the Purple Book, except for stick framing, we call it the Wood Book. So a lot of floor ceiling assemblies, maintaining an hourly rating through the floor lines. How do you do things like that? So that's a wonderful resource. We have the best technical team in the industry. Our construction services department, they can be reached at 1-800-NATIONAL. They are in the office from 8:30 to 4:30 every day Eastern time, and a great resource for that. We also, of course, have the construction design managers. There's 5 of us around the country.
So if you want to connect with your local construction design manager or CDM, you can go to our website, at nationalgypsum.com/expert-connection, and you would see all of our information there.
The best resource we have is National Gypsum Intelligence. It's powered by AI, and it is a wonderful tool for you to log into our website, nationalgypsum.com. There'll be a spot right there. You can't miss it. Type in exactly what you're working on, what questions you have. I need abuse-resistant board with an STC or whatever it is, UL design, whatever you need. And it will pull from all of the resources that we've just talked about, Wood Book, Sound Book, Purple Book, and then a whole lot of resources that we haven't talked about today that are on our website, and it will provide the answers for you. So it's the NGI tool. It will show you all of the sources, and if there's a specific source you want to dig into a little bit more, just click on that, and you're right where you need to be.
A lot of resources and a lot of ways people can contact either of you or just National Gypsum in general to find out more information. So Great. Well, thank you both for this conversation. I learned a lot today. I think our listeners probably have too. So thank you.
Appreciate it.
All the resources we've mentioned today will be added to the show notes, and all of our podcasts can be found on your favorite platform or by visiting nationalgypsum.com. If you have questions or an idea for a topic, email us at podcast@nationalgypsum.com. Hope you'll join us again soon. National Gypsum Company is the exclusive service provider of reliable, high-performance building products manufactured by its affiliate companies and marketed under the Gold Bond, Proform, and Permabase brands. The National Gypsum name has been synonymous with high-quality, innovative products and exceptional customer service since 1925. The information provided in this podcast is for general information purposes only. For specific building or design questions, please consult with the 1-800-NATIONAL Construction Services team or your regional National Gypsum Construction Design Manager. Always use products according to the manufacturer's recommendations.